Welcome everybody to reInvent 2021. My name is Bridget Johnson. I am the GM of Access Analyzer in AWS Identity. And today I'm really jazzed to talk about permissions. As most of you know, it's my favorite topic. And today we're going to talk about the least privileged journey. And one thing that I really like about this talk that we've put together is essentially we talk about the new functionality that Access Analyzer has launched this year to make it easier for you to get to least privilege, but we also dive into some really cool policy topics. So it's a little bit of balance of diving deep as well as seeing how Access Analyzer helps you get to the right permissions. So here's the lineup for today. First, I'm going to give a really high-level overview of AWS Identity, what you need to know, how the pieces work together, and where permission plays a part. Then we're going to dive into permissions, what tools you have at your disposal, and how they work. And then we go into my favorite part, the permissions lifecycle, and how you get to set the right permissions. And we'll talk about setting permissions, verifying permissions, refining those permissions further, and at the end, I'll test your knowledge. Throughout, we're going to have several demos, and then we're also going to have pro tips. So as you follow along, make sure to keep track of those pro tips, although I do recap them at the end. All right, AWS Identity overview. This is what we hear all the time. Who can access what? It is pretty simple phrase with a lot of complexity underneath. So we talk about the who. These are your developers and your applications. Developers, builders, anyone, any human access that you need. And applications are your systems, your workloads. Then you have the what. The what are your resources. And this is an ever-growing list of resource types across AWS, as well as your resources that you're provisioning. And that's your buckets, your Lambda functions, your batch jobs, your step functions, your secrets, the list goes on. And it's pretty cool how much is out there. But when it all comes down to it, my favorite part is the middle, the thing that connects them together, and those are permissions. And that's where the access comes in. And that's what we're going to talk about today. But before we do, this is what you need to know about identity. Here's my top list of things that I want you to take away beyond the permission space. First, hopefully you're using multiple accounts. You want to separate your workloads into multiple accounts across multiple environments, potentially regions as well, whether that's development environment, production environment. And as you grow those number of accounts, because you're growing your workloads, you're going to want to govern those from AWS organizations. More and more services and integrations are coming out of AWS orgs. And if you do anything at the end of the year, beginning of the year, you want to start fresh, please go check out the list of all the integrations with AWS orgs and see what's going to be useful to you to help you govern all of your AWS accounts. All right, now that you got a bunch of AWS accounts, you're going to want to grant access to all those accounts. And you're going to want to make sure you have a central identity management solution to do that. And the recommendation here is AWS SSO. AWS SSO allows you to either create your own users and groups and attributes and all the goodness that you need for identity management, or it allows you to bring your own identity provider. And then, of course, grant access to AWS accounts. Speaking of granting access to AWS accounts or permissions in AWS, I'm just going to call it like I see it. Please use short-term credentials, right? There is a Twitter thread that I absolutely love that said, hey, I don't think we need IAM users anymore. And that's actually true. Right? So more and more, the use case for IAM users is going down, and the use cases for short-term creds with roles is going up. And you can do, for your human access, use federation. For your workloads, use application roles. Please rely on short-term creds whenever you can. This is a security best practice, and it's in your best interest. All right, then you have a ton of resources that you want to grant access to, and you need to organize those resources. And tags is your answer here, along with resource groups. I'll demo a little bit of this today, and it's super fun. And then we get into the permission land. All right, start with a permission land so you can have a journey to least privilege. You're going to need a data perimeter and some guardrails. I'm not going to talk about this specifically today. We'll touch on some key aspects that help you establish a data perimeter, but there are workshops, there's blog posts, there's a lot of videos on data perimeters. So I encourage you to go check out that content. And then we get into the fun part about the journey to least privilege. And that's what we're here to talk about today. So let's dive into permissions in AWS. All right, so we talked about who can access what. And at the end of the day, it's all about the access controls. That's the middle that connects those two together. And how do those access controls come to life? Well, there's two parts. The first part is your job. it is your job to specify the access controls. Who can access what and under what conditions? And you do that using policies. And we help you with those jobs with a lot of tools. But that's what we're going to talk a lot here today, is specifying that access. And then you have AWS's job. Our job is to enforce. So for every request that comes to AWS, we enforce the access and that you define and allow or deny it. So to specify, what is the goal? The goal is to adhere to the principle of least privilege. POLP. I put this in there mainly because I really wish it was PLOP, because then I could tell people that I worked on PLOP and it would just be so funny. But what it really is least privilege. We hear it all the time, and it's something to really consider. And it's about granting users and systems the narrowest set of privileges to complete the required task. And I want to double click on this term required task, because when you think about your different environments, your tasks and your requirements are going to change. So for example, in your development environment, it might be part of your developer's required task to actually experiment and explore. I have several engineering teams, and they do this. They say, hey, Bridget, this new service came out, or this new feature came out. I'm going to run an experiment to make things faster, better, more reliable, better visibility into our systems, whatever it is. And you want them to be able to experiment and explore so they can innovate. They do have the agility to move fast, and you give them freedom to go and build. But on the other hand, you might have a production environment where you're serving your customers all day and all night, and you want to make sure that dangerous actions are prevented. You have an accountable security posture, and you have cost-effective solutions. And this is where the rubber meets the road. And we're going to talk about tools to balance this today. All right, just going to say it. IAM policy language, my favorite language. The PARC model, hopefully most of you are familiar with, but I'll go through it really fast. This is the language where you get to specify access. So you have your principal, which is the entity that is allowed or denied access. The action, this is the type of access that is allowed or denied. Thousands of actions across AWS, very fine-grained permissions here. The resource that the action is acting on, and then the conditions on which will apply. One pro tip here that I snuck in was a lot of people think they can use the $account policy variable in the resource ARN. It doesn't work. Don't use it. You actually have to specify account. The only place you can use a variable in the ARN is the last part. So where you see pickles in the screen, that's where it is. All right, so with that policy language, you need to specify. And there are two ways to grant access. Now remember, access is denied by default. And so how do you actually give access? Well, there's two ways to do it. One is the IAM principal policy. These are policies that are attached to roles. I'm not even going to talk about users. They're attached to roles. And you have your managed policies that are standalone entity, and they can essentially be attached to multiple roles. And this is like a rinse and reuse type of scenario. You also have inline policies, and this is where you have a specific need, maybe like a proof of concept, or like, hey, we only want to grant this role this permission one time and nobody else should get it. That's when you would use an inline policy. Then you have resource policies. These are policies that are attached directly to the resource. So fun fact, the IAM role is the only resource that has both an IAM principal policy and a resource policy attached to it. That resource policy, most of you know, is a trust policy. And then there's the most famous resource policy of all time, which is your S3 bucket policy, and an up-and-coming contender of the access points as well, and some others as well. And resource policies are good for direct cross-account access. All right. So you've granted access, but you probably want to restrict it too. Say like, hey, here's some rules that I just want everyone to abide by. So if you want those rules and those limitations to be up at the account, organizational unit, or the entire org level, you're going to want to use service control policies with AWS organizations. And this allows you to restrict access across an entire organization. These are things you just don't want to happen. Or you say, I want to restrict access to everyone but my one network admin or central admin. Then when you pop into an account, you could use permission boundaries. And this basically allows you to say, hey, developers, you can grant access, you can create roles, you can apply policies to roles, as long as those roles have this permission boundary. And that's the upper bound of permissions. And this helps so developers can't escalate privileges and just attach admin. Then you have VPC endpoint policies, which require that all traffic stay in your VPC. And then block public access is a control that's for S3 right now. And it basically blocks existing public access and any new public access. So if you don't need public access, go turn on BPA. My first pro tip for you today, use the right permission tool. So let's give you a little test. If you want to restrict powerful actions except for admins, what are you going to do? Service control policy. If you want to grant only the action your role uses, you're going to use a permission policy because you're granting access, an IAM permission policy. Developers can manage roles safely. You're going to use a permission boundary, and grant direct cross-account access. You're going to use a resource-based policy. All right, so now you know all the tools. We're going to talk about how AWS enforces this. And this is one thing that I really want to stick and to remember. So for every access request in AWS, there are two parts. There is the context, and there are the policies evaluated. And then AWS to enforce uses those two pieces of information. And we're going to talk a lot about the context today as well as the policies. But with the context, this is something that AWS services make, AWS itself, and some of them are dependent on what you pass in, right? And so this could be the action you're calling AWS, EC2 terminate instances, you're calling it on a specific resource. Maybe that resource has a tag, so the EC2 will put that in the context. Maybe you're calling it from CloudFormation, AWS will put that in the context. So it makes this giant context. And then the policies basically say, hey, there's a bunch of things in the context. I'm going to check and see what matches based on what's specified in the policy. So all the policies are evaluated, and then based on the context and what is in there, out comes one of two things, allowed or denied. There's no gray area. It's either yes or no granting access. So when you're stuck or when you're trying to think about access, think about what is in the context and what are the policies, and then what are the rules of comparison and matching. All right, so how are all those policies that I talked about for you to specify access evaluated together? And this is how I think about it. First of all access is denied by default, starts with a deny. So if you're using SCPs, that means there's an SCP that you have specified, the SCP must allow access. If you're using a permission boundary, that means you've applied a permission boundary, then the permission boundary must allow access. Okay, those are the restrictions. We haven't gotten to granting yet. If you are in the same account, the identity policy or the resource policy must allow. There is a caveat here. For KMS keys and assume role for the IAM roles within the same account, the resource policy must grant access. This means that if you grant some role, assume role star, they cannot actually assume every role in the account. The trust policy must also grant access. For direct cross-account access, both the identity policy and the resource policy must allow. And so we think about this as like the hotel room with the two doors that need to open. Both the resource policy must say, yep, we're good, and the identity policy must say, yep, we're good, and then access will be granted. And if you're using a session policy with roles, the session policy must allow and the identity policy must allow. All right. And then one thing I want to talk about this time was, and something that's pretty powerful, is that AWS relies on the same permission model that you do for your workloads. And as AWS innovates and creates new services, there's been more and more use cases where AWS services need to act on your behalf because they're managing things for you, or they're doing things on your behalf. So you get to be building and AWS can be managing. And that's great. But how do you actually grant access to AWS services? Because you need to do that so we know it's okay to perform actions on your behalf. There are three ways. The first way is a service-linked role. This is a role that's directly linked to an AWS service. The permissions are predefined and the trust policy are predefined, and they cannot be changed. One example is IAM Access Analyzer. When you enable it, we create a service-linked role in your account, and we use this to go and look at your buckets, look at your roles, and check the configuration and determine if there's public or cross-account access. And then we generate a finding if there is. One pro tip here is that if you are choosing to use an AWS service that requires a service-linked role, it is pretty darn safe to allow access to create that service linked role because the permissions can't be changed, the trust policy can't be changed. So basically you're saying, I trust the AWS service to perform these actions for me. The second one is service roles, and we try to use service roles when the permissions need to be customized. And this would be like in Lambda, we don't know what your function is going to do because you're going to author a function. And so you need to specify the permissions, and then as well, you need to specify the service in the trust policy. My pro tip here is to specify the service in the trust policy and also break it out. You don't want to mix and match too many together. It'll be hard to audit and monitor that access. And then finally, the third one is requester permissions. So this is where AWS services use temporary credentials generated from the requester. And you'll see this a lot when you use AWS CloudFormation. And essentially it'll say, okay, I'm running this template and I need the permissions from the requester to perform these actions on your behalf. So the pro tip here is that the principal needs access for all permissions that AWS will run on your behalf. All right, so that's the permissions deep dive. That's how you specify, that's how you enforce. Now let's go into the permissions lifecycle to help you get to the right permissions. And I want to talk about least privilege. It is a journey. So many customers say, I just want least privilege right now. But guess what? As you innovate, as you build, things change. You might need more access. You might need less access. So it's a continuous life cycle in a journey. But how do you make that safe? And we talk about, first, you need a data perimeter. You need those guardrails to basically say, hey, this is all inside. That, you know, we have our outer bound. And so if it's a little bit broad, it's okay for now, but we're going to scope it down over time. And so then you're going to set, verify, and refine, and this will continue to go through until you get it right. And it will change as you innovate as well. And so today we're going to go through each three of these steps. So let's talk about setting permissions. Here are your tools that you get to define policies. Now, when you're exploring AWS, you don't know what you need. You're just getting started, or you're exploring what services you're going to be using. Maybe you're running some proof of concepts. You're going to start broader, and to do that, you can use AWS managed policies, or we've heard customers talk about custom templates. Now, AWS managed policies are broad. They are meant to be used as a getting started place. And so you'll want to take those policies, and then over time, you'll right size those policies as well. And so this is the second step. You've kind of ironed out what you need for your workload, or you've ironed out what your developers need to access on a day-to-day basis or specific use cases, and you're going to go right size. And this year we made it easier with Access Analyzer. We actually generate policies for you based on your activity in CloudTrail, and then you can customize further if you need. Okay, so you've right-sized your permissions, everything's hunky-dory, and that's all great. But you're like, you know what, Bridget? I really just want to do it myself. Like, I'm a DIY type of person. I want to get super, super fine-grained with those conditions, which I totally value because, you know, I love conditions. But we want to help you. And so if you're authoring custom policies, whether it's some template you started with, found online, or you're just modifying an existing policy, you can validate that with Policy Validation and Access Analyzer, which is also a new tool that we launched earlier this year. All right, so let's talk about policy generation. This is the high-level workflow. You run your application or task, you request a policy from Access Analyzer. Access Analyzer goes and does the work, looks at your CloudTrail activity, and then you get to customize further and apply it. Fun fact, when I was doing my demo for this, I was like, all right, I'll try it once and then I'll do the recording. And I went through it and I was like, wow, that was super easy. And I wish I had recorded it the first time because it worked like a charm. All right, so this is how it works. You would run your application. In my demo, I'm going to use a Lambda function. Then you go to IAM Access Analyzer and you request a policy. So we need to know what role was used. Makes sense because you're trying to scope down that role. What time you want to do it. I did it for a day because I ran a Lambda function and everything was executed that day. What trail to look at. And you make sure you need to have permissions to that trail as well. So if you're using an org trail, you need to make sure that the role Access Analyzer uses has access to that. And then what regions you want us to look at. You can select all regions, or you can select one region that you know you ran in. All right, and then Access Analyzer gets to work, and this is my favorite part. It goes to your CloudTrail, it looks for all the unique events, and then it takes those events and it maps the CloudTrail activity to the IAM action for over 50 services and more on the way. And then it generates a policy that adheres to IAM policy language. We also include any dependent actions that you might need, and we put spots for resources. This is literally my favorite part, because then you can basically say like, oh, I know my bucket name, and put the bucket name in there, or oh, I know my resource group, and specify the resource group. You don't have to craft the yarn, you don't have to know everything, and we put it with the applicable actions as well. And so that's where you can customize further. If you need additional permissions, then you can specify that as well. We call out services that you use that we don't cover at the action level yet, and as well as the resource permissions as well. So, all right. So this is the demo. I have, so Pickles is my horse, introducing Pickles for the first time in this talk. He's a little bit of a unicorn and he's quite special, but he has a pasture. In his pasture, he has, a little shelter, water, hay, and he likes to audit his pasture. He likes to walk around, but he built a Lambda function for it. And so his Lambda function checks and makes sure everything's in the right place and operating as needed. And so he will, but we want to right size his permissions. Right now his permissions are a little broad. We need to right size them. So in the demo, I will start with a Pickles pasture audit role, and I will show you my Lambda function. I'll run the Lambda function. We'll request a policy from Access Analyzer. Then we'll wait a little bit while it generates the policy. And then I'll customize and apply the new right policy and run the Lambda function again. All right, so here we go to our demo. In this demo, I am currently in the Lambda console, and I'm actually in the US West 2 region, West Coast, Best Coast here. And so I have this Lambda function called pasture audit. This is the function that Pickles uses to audit his pasture. He grabs some instances in their instance type, lifecycle configuration for S3 buckets, secrets and secrets manager, and it's all managed through a resource group. And over here in the configuration, you can see that I've assigned a role to it called the Pickles pasture audit role. And this role, when I go over to the IAM console, will have pretty broad access. And I'm going to test this function just to let it run. That will generate some activity in CloudTrail, and then we can use that activity to generate a policy. So we only grant what we need. And you can see that because of the broad access, everything was allowed, and it ran through. So now I'm in the IAM console. I've clicked on the pasture audit role, and you can see it has broad access, just the services that I knew I was going to use, resource groups, taggings, EC2, S3, and Secrets Manager. But I want something more fine-grained than this. And so I'm actually going to click on Generate Policy here. I had generated one previously. I click on Generate Policy, and then I am going to put in my CloudTrail. I'm going to do all regions. Maybe I made a cross-region call. And then I have a service role that goes and looks at CloudTrail. And I'm going to go and wait for the request. All right, and I'm in the IAM console. I have actually generated the policy. It has gone, and you can see this is what Access Analyzer found. Really interesting that CloudFormation was in there as well. This is the policy. It has all the actions and everything that you need. It aligns which actions support resource level permissions and which one don't. I'm currently filling in the templates. So I need to fill in the region as well as the account ID, copied and paste that so you didn't see me typo, all of that. And because I'm doing an audit, I'm actually going to make the resources applicable to Pickles, or all of the things in the account, which would be in his pasture because it's a pasture audit. And what I like here is you have the full editor at your disposal. And so you can see at the bottom, there's actually errors. Those are because these are template items and nothing real. I'm going over to my Lambda function now because I had specified a resource groups that Pickles use based on tags and all the resources in there. And I want to make sure the name matches. And sure enough, yep, I'm going to grab Pickles pasture and put it in my policy. And so instead of a template group name, and you can kind of see as I fill out, the errors go away. But the other thing is on the right-hand side here, you can add more actions if you want. You can add more resources using the select thing over there. And then you can also add a condition if you want to add some conditions along the way. And then I'm just going to click on it. Or I'm going to finish it out. I want to audit all the secrets in the account. Should be all good. Kind of give it one last run through. Look and see if there's anything else I want to go. You can add a condition. I don't have any security warnings, so that's great. I'll click next. And I'm going to give the policy a better name. So you'll want to generate a good name that's relevant. And this is our pickle pasture audit. And I'll name it fine grained because I have a broad one as well. And I'm going to remove the timestamp because I don't need that information. I'm just going to say based on its activities, and you can kind of see the summary as well. I could tag it if I wanted to. I'll create, and it will attach the policy right to the role that it used, but it keeps the broad one as well. So I want to remove that because I'm in development and I'm still testing. And so I'm going to detach that broad permission, and then I will go back over to the Lambda console, and I'm going to run my Lambda function again. But I will show you the permission summary here, and this is the well-scoped policy right here. And then I head over to the Lambda console. I kind of gave it a minute for that policy to propagate. And I'm going to test it again, make sure it works, and then we're good, ready to go. No access denied. We're all good. We have a nice, well, fine scoped policy. Run it a few times. If you updated it, that would be fine too. All right. So now that we've done that demo, I haven't forgot about you, custom policy authors. We love conditions, right? And so my next pro tip is to become besties with those conditions. And when I think about conditions, I really think about, okay, grant this access, but only if these conditions are met. And so in this policy, you want to say allow EC2 start and stop instances on any resource as long as that resource is tagged with Project Pickles. All right, but only if that resource is tagged with Project Pickles. All right, so here are the three parts of conditions. The first part is the condition operator. This is the type of operator used to compare the value in the context to the value in the policy. Remember, we talked about the context in the policy. This is what is used to compare. These are defined by AWS. You have string equal, string like. There's a whole documentation page on what operators you can use. My pro tip here, if you don't have wildcard in the value, don't use string like, just use string equal. You want it to match. All right, so you have your operator. Then you have your condition key. The condition key is a predefined key, and this key is used to look up values in the context. This means you cannot use wildcard in the key. We literally need the specific key to go get the value from the context. So then we can compare it to the value in the policy. These are predefined by AWS. You can have service-specific ones or global condition keys. One example here is principal is service. And then the third part is your condition value. This is the value you define. This is the value you want to be true. So for example, you would say only allow if principal is an AWS service, or is it true? Or that resource project is Pickles. Or you can actually, fun fact, use a single value condition key. We'll talk about multi-value in a second. A single value condition key as a value in the policy itself. And this essentially looks up in the context and essentially does a find replace to compare it. And so you might just want to say, is the resource tag the same as the principal tag? All right, so when you use multiple conditions together, if you want all conditions to be met together, you can put them in the same statement and they are ANDed. If you need this part of a condition or this part of a condition, you need to separate them out into two separate statements. And so here we have create service linked roles for Access Analyzer, or create a role as long as there is a permission boundary set, it's called via CloudFormation, and the request tag or the request tag project has a value of either pickles or bubbles. Now, keep in mind, a lot of people think that they need the multi-value operator if they have a multiple list on the right-hand side where that OR is. But if you have a list, it's ORed. And you only want to use multi-value operators when there's a multi-value condition key. So let's talk about those. So multi-value condition key is when for that condition key, there are multiple values. So in the context for AWS tag key, it says project, center, cost center, and name. That means that you're trying to tag with all three of those. Multi-value condition keys are documented. They usually end in S, and they are specified in the AWS documentation. So only when you have a multi-value condition key do you want to use for all values or for any values. And here's the reason why. With for all values, basically the operator says, is the context a subset of the policy? If there are no mismatches, then the condition applies. Now we have to remember that any empty set is a subset of all other sets. And so essentially, if you put in for all values and tag keys, AWS tag key is not populated, either it's not sent in or it is, or AWS doesn't support that condition key for that action, then the condition matches and it will kick in. And if you're using an allow, that will grant access. And that might not be what you intend. So for the first two examples here, you can see that AWS tag keys has project, cost center, and name. And then in our policy, we have project and name. Well, guess what? There is a mismatch, cost center, and so that's not a subset. And then tag keys is empty. Well, empty set is a subset, so that does match, and the condition would kick in. Now, for any values, you're going to be looking for an intersection of the policy. If there's at least one match, then the condition kicks in. And so for project and bubbles, there is an intersection, which is project for that third example there, and an empty set, there's not an intersection, so the condition would not kick in. And so what are the noteworthy condition keys here? These are my favorite. You have a resource tag, request tag. These are when you're using attribute-based access control. Called via first and last. This is when you're actually going through different AWS services and you want to say, hey, this is allowed, but only through CloudFormation. Or, hey, this access is granted as long as KMS is working on that S3 bucket. Principal org ID is another good one. This is great to put in your resource policies like, hey, this access is allowed, but only if the principal is coming from my org. That has to do with that data perimeter we talk about. And then principal ARN. This is good in SCPs where you want to say deny everyone but this principal ARN like a central admin. And then principal is AWS service. If you're trying to restrict using source IP, then you want to say, okay, but allow AWS services as well. So these are the noteworthy condition keys that we have. And using conditions with denies, I just want to pop in here. So these are some beautiful policies that I got from a coworker of mine. And let's go through them. So the first one says, deny all these S3 actions on this S3 buckets if these conditions are met, right? And that means that it's the deny kicks in if the principal org ID is not my org and the principal is not an AWS service. And the and comes from those two that are in the same statement. Okay. Then on the other side, we have deny access to all these S3 on this bucket if these three conditions are met, right? So the deny kicks in if it's not coming from one of the specified VPCs, it's not one of the source IPs specified, and it's not an AWS service and not through an AWS service. And you can see that VPC list that's in orange on the right-hand side policy, that VPC list is ORed, right? So it can come from VPC 111 or VPC 222. And if it's not one of those, then the deny, that condition is met and the deny would kick in along with the others, right? All right, so that's a super fun policy. I like it because shows you all the different operators that exist, and there's more. It shows you a bunch of different condition keys, and it shows you how multiple policies work together. And one thing here is you don't want to put the for all values in there, because if it was empty, then the condition would be met, and maybe that deny wouldn't kick in when you had intended. All right, so for all of those custom authors out there for crafting your own policies, you can get the seal of approval from Access Analyzer. And so Access Analyzer earlier this year launched policy validation, and we have over 100 checks to help you author secure and functional policies. This is in the IAM console. It's also available via API. A lot of customers are starting to integrate it into their pipelines and different tools to validate access. And we're always adding new checks. So if you have an idea, please let us know. When you look at your checks, I need you to look at the security checks first. This is where AWS says, hey, this can be overly permissive. Then you want to look at the errors, because this is where we think policy contains errors that prevent the policy from functioning. This could be an invalid action or missing comma, all of that. Then you can look at general warnings. This is when things don't conform to best practices, but the issues are not security. And then suggestions. This is where it doesn't impact the permissions of the policy, but might want to adjust it. All right, so I could not bring myself to put a bad policy on a slide. So this is kind of a good policy, shortened for slide length here. But we're going to start with a bad policy in this demo, and then we'll use the policy validation in the IAM console to work through the kinks and get it in tip-top shape. And so this is the policy that I had to essentially do some role management items, and we'll go through there. All right, so let's go to our demo. All right, I'm headed over to the IAM console. I am going to get to create a new policy, because I want to use policy validation in the console and work through my errors one by one. A lot of customers do this, and then they copy paste their policy into code or into something that they want to use to validate, or where they store their policies. So I'm in the JSON editor here. This is for all you do-it-yourself DIYers. And I have 2 security warnings, so I definitely want to look at those. I'll look at those last, but I want to get rid of my errors first. And so it says invalid action. I click on it. It brings me to the part of the policy, and I'm like, list pickles policy. That's wrong. List pickles role. Obviously, I was very excited to talk about pickles in my demos. And so I'm going, those are invalid. It says region not allowed. It's pretty actionable, and if you need to learn more, then you can click on that link. It'll actually bring you to the finding itself. And then for this one, pickles is not a valid condition key, and so we want to remove that. All right, security warnings. So this is where I accidentally used for all values with a single value condition key. So both request tag and permission boundary are single values. So I'm going to remove that, and so we just use the string equals operator on that. And that is my policy, and now I don't have any security warnings, which is great, and I don't have any errors. So now you've looked at all the tools and all the ways to set permissions. We're going to move on to verifying permissions. So after you set them, you want to verify. What do you want to verify? Most likely you're going to want to look at overly permissive access, and it falls into 3 categories. One is public and cross-account access. And the tool to help you with this is Findings in IAM Access Analyzer. And it's free. You can enable it by default, or you can turn it on, and then it will actually go and look at all of your public and cross-account access for specific resource types. You also want to look at pass role permissions. So pass role, it can escalate your privileges if you allow pass role on everything, because most of you have an admin role in your account. And to help you do this, you can actually use policy validation, which is what we just looked at. And then finally, you want to scope down any powerful permissions. This could be managing network or managing IAM permissions. If people don't use it, you want to get rid of it. All right, so let's talk about cross-account access. This is possibly my favorite slide. All right, so there's Pickles the horse, and there's 2 accounts. There's Pickles pasture, right? And then there's the treat account, because Pickles loves treats, but he can't have them all the time. Otherwise, he'd get quite fat. But he does love treats. So in the pasture account, Pickles can assume the purple role, the horse role, and in that role grants him access to graze it's a Lambda function, to eat hay and to drink water. And that's great. That's what he needs. It also allows him access to say, you know what, he can go have an apple every now and then. That apple is in the treat account. Pickles can also assume roles in the treat account, and that gives him access to eat carrots. Now, since that bucket has an access point policy on it, it basically says, allow horses in my barn to grant access. Because the access point policy grants access, as well as the horse roll policy grants access, Pickles can eat apples. Now, there's a third bucket in that treat account, and those are human treats. Those are chocolate. That's treats for Bridget. And so we don't want Pickles to eat those. And so that policy actually restricts access and only to humans, or maybe a human role in that account. And you want to look at all of the places on this slide that have yellow. So those are your trust policies on the role, like who can assume these roles, the access point policies, and the bucket policies. And you would want to verify that that access is as intended. And so here are your tools to help you restrict public and cross-account access. First, block public access. If you are in S3 and you're creating a new bucket, please turn on block public access. Also, your existing buckets, you want to go and prevent existing public access that may be configured if it's not intended to be public. Principal org ID is a great one to use in those resource policies. Basically say, allow all this access as long as the principal is coming from your org, within your org. It's a good perimeter restricting access. Principal ARN basically says, deny access to all except this ARN. It allows you to get pretty fine-grained in those resource policies as well. And then principal service name. A lot of time AWS services will need access to a bucket to maybe analyze your CloudTrail, to help you make decisions, etc. And so you'll want to be able to specify, okay, we allow this AWS service access to our bucket. All right, Access Analyzer, findings in Access Analyzer. So once you enable Access Analyzer in your account or for your organization, Access Analyzer continuously monitors resources for 7 resource types. We use automated reasoning to determine public or cross-account access, and then we generate findings for you. So you get to go verify and match your intent. And then you can archive these if they are intended, or you can essentially, remediate the access. So I dropped this word automated reasoning in there really quickly, and I want to double click on that because you're like, what was that? And automated reasoning is something that we are using all across AWS. I personally love how we're using it in Access Analyzer because it allows comprehensive analysis of your permissions. And essentially what it is reasoning is the process of applying logic. And we can infer new conclusions from known facts about the systems. And when you automate it, you can reason about an infinite number of paths, which allow us to make universal statements about your external access. And this is a comprehensive analysis because there's so many paths of permissions. And with that, we turn it into public and cross-account findings in Access Analyzer. The coolest part about this is that those first 4 things on the slide, you don't even know you're using automated reasoning, right? AWS does it all for you to make sure that our analysis is comprehensive. So let's check it out. We're gonna have a demo, and I've already enabled Access Analyzer in my account, and I'm going to go verify some bucket access and some role access to make sure it is what I intend. So let's go over to the demo and see what it's like. Okay, I am in my treat account. You can see I have 3 buckets here. I'm going to go over to IAM Access Analyzer. I've already enabled it, so if you haven't done that, that's something that you will need to do. You can see that the Oreos bucket has some external access, and I want to investigate this account that starts with 36 because that's an old account from my previous demos, and it doesn't need access anymore. And so one thing that's really cool is while you're editing the bucket policy, you can actually preview public and cross-account access. If you have Access Analyzer enabled, it'll just use your analyzer and tell you what's up. And then as you edit bucket policy, you can preview it again and make sure. So I've deleted that account. And also while I'm in here, I'm going to use the best practice and make sure that all of those, any principal access it is from my org. And both of these accounts are within my demo org.
And so you can see there's a little error there. I fixed my comma, and I want to preview access again. Now this is a really interesting one because it's going to tell me that the 3 cross accounts that it had are resolved. But I have 2 new ones, and these are actually the 2 that I intend. But we actually added that condition value at the end, so it generated a new one to let you know what type of external access it is. And if I go to this specific finding that I had before, it says resolved. Now, those were my buckets and everything else is intended. The other one are this account that allows the Pickles Dev Treats role, and it's actually intended. And so I'm going to create an archive rule because I don't need to address it anymore. I'm allowing that access. And so I said those are the trusted horses. And I'm going to use the AWS account value to basically say this is a new archive rule. So anytime you see this access, then from this account, it's okay. And these are trusted horses. You can also see I have one for our central security team, and then it shows only the active and the active findings thing. And this is what I would want to go look at. And that's Access Analyzer.
So now that you've looked at your public and cross account access, you want to look at your pass role permissions. So with this policy is pretty scoped down. But let's imagine that I took this policy off and I replaced it with something else, but I couldn't do that. And I just said, hey, Pickles, you are allowed to pass role any roles to anywhere, right? And if I allowed Pickles to do that, he would most likely say, I'm going to pass that admin role into that Lambda function, and I'm going to go get some more treats, all the time, including the Oreos. Which is not good. And so essentially you want to scope down access. And so with pass role permissions, you want to say you are allowed to pass role on these specific roles. Using a namespace really helps here. So Pickles is allowed to pass roles that he creates in the namespace Pickles, and you can only pass to Lambda functions. And so this will help you restrict access to pass role permissions, which is another pro tip. So let's see it in action because you can use policy validation with IAM Access Analyzer to do that. So I have a policy that has pretty broad pass role permissions. I'm going to put that in the policy editor in the IAM console. I'm going to look at what the policy validation says, and I'm going to restrict access. So let's go over to our demo and see it in action.
So here I am back in the JSON policy editor, and I am going to dig into pass role. And you can see I have a security warning. This is what I use to actually create my Lambda functions. And but pass role is pretty broad. That means I could have passed admin into that Lambda function, and I don't want to do that. I want to be more specific. And so I'm actually going to specify specific resources, copying and pasting. The Pickles aren't here, so y'all don't see me make a typo. And so this basically says, hey, with this policy attached, you can pass any role that starts with pickles - star. Our check actually looks for 7 characters. But I'm also going to add this condition that this you can only pass to Lambda. And you can see here that I assumed it was AWS when I first started, and then I was like, oh no, it's an IAM condition key. And so the policy validation helped me with that. So we're all good.
All right, so we have set permissions, we verified. Now we want to refine, and we've refined a little along the way with the verification, but we're going to refine further. And what are your tools to do that? First and foremost, you want to clean up unused roles and definitely the IAM users. And to do that, you're going to use role last used and access key last used. All right, so go in, you go to the console, you can call it programmatically, find things that aren't used, channel your inner Marie Kondo, and really clean up those roles that are not used, because that's just access lying around that you don't need. Then for the roles that are in use, you want to double click and refine them further by identifying unused permissions. And to help you do that, we provide service last access and action last access. And if you didn't know, we actually added a few more services to action last access this year that we'll show you as well. And then when you find, when you're like, okay, I want to bump up some of those guardrails across my accounts, we actually provide service last access for SCPs. So you can go look at your SCPs, see which services you haven't used, and then yoink out the ones that that you haven't used and just deny access. Like, we don't use that here. We're good. I like to pick on directory service because my office mate used to run directory service. And so maybe you don't use directory service and you're just going to deny it across your organization because you rely on something else. All right, so we're going to do a demo here. And essentially, I'm looking at a role that I have had. I'm looking at the pickles role, and I'm going to look at permissions that I haven't used. I'll look at everything I've granted access to, and then I will remove access that I haven't used. And so let's go see it in action and look at that last access information. And here's our demo.
Okay. And now I'm back in the IAM console, and I want to look at last access for this pickles pasture audit role. And if I look at the permissions, I have my fine grained attached, but somehow this IAM read-only access got attached. And I want to look and see, and like, okay, the IAM access is coming from the read-only access, and it hasn't been accessed. CloudFormation also hasn't been accessed. I want to dig into S3 and just make sure that everything that's granted is also used, which was the case. So that's good. And I could do the same for EC2, and I can also do the same for IAM. Here, there's a lot of IAM APIs. And so I was kind of like searching around trying to look for stuff, but it looks like and the service has not been used and none of the actions as well. And so I feel pretty confident, and I'm going to actually remove that IAM read-only access from this role. And so I'll do that first, and I will detach it. And then I'm actually going to go into the fine-grained audit, because I can actually refine it even further than I had before, because CloudFormation was added in the previous demo as a dependent action. And for my use case in my audit pasture, I don't need CloudFormation. And so I'm going to go in and I'm actually going to remove it from the JSON itself, even though I had specified it. So I'll remove it here, make sure we're all good. I don't have any other errors or security warnings. I'm going to review the policy. I will save the changes, and then I can go back to Access Advisor and make sure that everything that is granted is actually used. And so let me go back to that role itself, Pickles Pasture Audit, and then get to Access Advisor here. And then you can see from the list below that everything has actually been used, and that's a pretty fine-grained policy.
All right, folks. So I've given you the lowdown on setting permissions, verifying, refining access. We've talked about conditions, pass role, all of the goodness in there. And let's challenge. So require a specific tag key and value when creating a secret in AWS Secrets Manager. What are you going to use? An identity policy. So this is a new secret that's being created. You want to have an identity policy that requires that. All right, implement a guardrail so that no one outside your organization can access data in a bucket. A resource policy. This is going to go on the bucket itself, and you will use a condition to require that access. All right, pick the right condition key. Prevent everyone but your network admin from creating and attaching internet gateways. What condition key are you going to use? Principal ARN. You will want to be, that's the everyone but the network admin. You'll use the role ARN there. Allow the creation of infrastructure, but only when using CloudFormation. All right, you're going to use called via first. And this is essentially the first service that you're calling via through, and it will be CloudFormation. All right, true, false. If you need to evaluate more than one type of condition together, you need to keep them in the same statement. True. And next one, you can always use any condition key anywhere in an IAM policy. False, but you can use it in the values or in the ARN, the last part of the ARN. If you have a list of condition values, like multiple source IPs or multiple tags, you always need to use for all values or for any values. False. This is one of the biggest mistakes in policies. And so only use for all values and for any values if the condition key is multi-valued. And you can always check that in the AWS documentation. All right, pro tips here. Let's recap. Use the right permission tool, become besties with conditions, restrict public and cross-account access, restrict pass role permissions, enable IAM Access Analyzer, validate your policies, and use policy generation with IAM Access Analyzer. I want to thank you for your time today, as always. There are several other talks that I have given on permissions over the years. In previous talks, you might want to look them up if this is your first stop. We talk about permission boundaries and SCPs more, ABAC as well. So give those a whirl. And I want to thank you for joining us and have a great day.